All right, so let's get started because I've got a lot of material. So this is a talk about intrusion detection and threat hunting in the cloud. And this is about these topics in the cloud, but much of this is relevant to non-cloud environments as well. But the reason it's about the cloud is, so a little bit of background about me. So I've been a security lead in some of the largest AWS environments where I was responsible for various security initiatives and projects. Before that, I was at some security product startups. I've done some special projects in the defense, financial sector. I've kind of done a bunch of things over the course of my career. I've worked on a lot of large-scale security data analytics projects in the course of my career, about a half a dozen in total. Some were products you can buy, and some of them were projects that were private. And I'm currently working on another, and I'll show you what that looks like. So this is actually a sequel of sorts to a talk I gave last year about doing intrusion detection in the cloud. And this came out of experience over the past 2 to 3 years and what I learned along the way, my colleagues and I. This is a talk about technologies. It's not about products. I'm actually not going to try to sell you a product. This is pure research. No product company had editorial control over this research or the resulting talks. So the good news is it's pure research. It's completely impartial. The bad news is you have to endure my breathtaking PowerPoint and art skills. So I had no support from any marketing departments. So a little bit of data. So I gave a talk in the series last year, actually, an AWS event. And I gave a talk with a friend, and there was some data collected along the way. There was a kind of an anonymous survey done at the end. It was completely anonymous. And there were a few questions asked, and one of them was, what kind of intrusion detection, if any, do you use in your cloud environments? And the answer was kind of what I expected. It's mostly in network intrusion detection. 20% said host intrusion detection, and 20% said none at all. And when you start looking at some of the capability-based questions, it got interesting. So one of the questions was, to what extent do you monitor your cloud servers for anomalous or suspicious activity? And I was actually a little bit surprised. Well, I guess I was and I was not surprised to see that only about a third of people said, yes, we do this. That I'm confident we do this really well. The rest said either no, we don't, or maybe somewhat to some extent. And then the other question was, well, what about, if you're monitoring security in the cloud, what about, in addition to the server instances, what about the management plane, the management APIs, the serverless things, the stuff going on in the pure services? And a lot of people said, again, that either they don't have the ability to analyze and correlate that with what's going on in the virtual server fleet, or they just don't know. They may have some capabilities, but they're not sure. Only about a third said yes. And I think actually that these two are related. The fact that there's a heavy reliance on network intrusion detection, and there's a little bit of a blind spot when it comes to the management API and the services, and I'll explain why. So over the course of the past 2 years, what happened was I was security lead at a large AWS property. I was tasked with figuring out how to do network intrusion detection at customer requests. So I went to work on that. And along the way, I learned a lot of interesting things. I learned that it's actually pretty hard to do network intrusion detection in the cloud, in any real public cloud environment. It's not specific to one or another. It's hard to do because it's hard to get network data, for one thing. Much harder than in the terrestrial world. I like the word terrestrial for legacy environments, which is a word that Mark uses, so I'll steal that. I also found that once you do get it working, the results are actually not what you expected. It's actually very different than what I expected and what my team expected, and I'll show you what that looks like with some data. We actually found that in some cases we got better results and better detection, more accurate detection from doing behavioral detection using endpoint data rather than doing network intrusion detection, and I'll show you why. And then finally, this is the direction I've gone, and I found that there are free and open source alternatives to a lot of so I was doing this originally using commercial products, some black box IDS products, and some other commercial security products at great cost in time and effort and licensing and dollars and capital, and in every metric, it was at great cost. And I found that it's actually possible to do this on a very different cost basis using open source technologies. So first, so why is it hard and expensive to do? So I'm gonna go through this quickly because this is a little bit of background material from the first talk. So if you consider, so network intrusion detection is a technology that dates back to, anybody know when this technology was invented? It actually dates back about 30 years ago. It was originally invented. And it was never intended to be network intrusion detection and only network. It was meant to be kind of intrusion detection across networks, endpoints, hosts, and everything. But along the way, it became network intrusion detection for various reasons. So a network IDS assumes that, first, it assumes that we can detect security things like attacks, intrusions, and suspicious activity, that we can detect what we want to detect by monitoring the network. Because everything that we want to detect is going to use the network, and we're going to see it go across the network. There's a fundamental assumption there. Breaks down in the cloud. There are assumptions that attacks are rare and finite enough that we can make a dictionary of attacks. We can make a dictionary of signatures and code that describe attacks that we can identify by looking at network packets. We can maintain the signature dictionary faster than new threats can emerge, or we can keep pace with them. And finally, we can negate evasion methods. Evasion basically means sometimes if you do a pen test, you'll see that they'll start doing interesting things so that the IDS or the web application firewall or whatever technologies you have, they'll start encoding their data or doing creative things in order to, so that these security devices don't actually detect what they're doing. Those are called evasion methods. So in the cloud, like in the physical world, we have a choice of network or host intrusion detection technologies, and then we have a choice of open or closed source. Now, one of the reasons that it's hard to do this in the cloud is that in the real world, in the terrestrial world, this is mostly done by specialized hardware. Because if you want to sniff gigabit or greater line speed networks, you need certain kinds of high performance hardware to do this in real time without impacting performance. There are no such technologies. See, because the public clouds are multi-tenant and the virtual networks that we use are abstractions upon the physical networks, there is no place that we can bring our network, our hardware IDS into the cloud and plug it in order to observe our traffic, because it would violate too many security models for us to do that. Anybody used introspection? This is something that you see in products like VMware, virtualization products that you'd use on-prem. Introspection basically means that we instrument the hypervisor. The hypervisor can then observe everything going on between the guest virtual machines, and that allows us to do intrusion detection efficiently by just gathering network data from all the hypervisors. Right? This doesn't exist in the public cloud either, and probably for good reason, because if this did exist, this would mean that the cloud providers would have visibility to some extent into instance traffic between consumer virtual machines, which has some privacy considerations, obviously, so we don't do that. So there are several ways to do network intrusion detection. So if we consider a typical AWS environment, this is an EC2 environment. We have internet gateways in front of balancers, in front of web server workers, in front of data layer instances. Up here, there'd be some balancers and some cache servers. So one way to do this is we take out the internet gateway and we put in a virtual firewall IDS instead. And that way we can see everything going in and out the network, because that's the only way in and out. And so that's one way. This, I couldn't do this. Now in my case, this can be done and people do this and it works fine in some cases. In my case, I couldn't do this because we were operating really, really large websites that were in the business of getting overloaded due to traffic events. And when a traffic event happened, these websites would have to auto-scale very quickly in order to satisfy traffic demand and deliver user experience. And I simply couldn't auto-scale these fast enough not to interfere with the user experience. And there's also the issue that if these are in line and the only way to get in or out is to go through these are now critical infrastructure, which means the security team, if they own these, is now in the critical infrastructure business, which some security teams are prepared to do that, but not all of them are. So the other thing you'll see people do a lot is they will delete the internet gateway. So now there's no direct internet connection out of the EC2 environment, out of the VPC. And instead, there's a direct connect or a VPN back to the on-prem data center. And so you backhaul everything from your VPC to your data center and your offices where your physical next-gen firewall IDS hardware devices can do their thing. And so this was not an option for me operating in a pure EC2 environment, because I didn't have anything on-prem. There was nothing back there. But this is an option that can work. There's still more options, though. We're still not done. So there's a company that makes a kernel shim that is essentially a virtual tap. And so what happens is every EC2 instance gets a virtual tap, which sniffs network packets, copies them, and then sends them all to a collection analysis engine, and then where they finally arrive at a network intrusion detection sensor or a set of sensors. And so now, again, we don't have anything in line, so there's no bottleneck up here, but we have to install and maintain all of these little network agents, these little network data collection agents on every instance. So obviously there's some overhead there and some cost. You don't necessarily have to buy a product to do this. If you have a really good network engineer, if you have a really good network team, there are ways to do this using open source tools and some network trickery and magic. It's not a simple thing to do, but it's possible. Now, what about containers, though? Because we're not, chances are your environments don't look like this. Your environments are probably not just EC2 instances today. Most environments, who's running, say, Kubernetes, for example, which is a really popular, right? So most of our environments are no longer most of our environments are more likely to be container and container management environments than just EC2 instances. So how do we do intrusion detection? How do we see what's going on when we have containers? Well, as you can imagine, we're really not going to see what's going on in the container nodes, the container hosts. We're not going to see east-west traffic between container workers. And chances are we're not going to see east-west traffic between the container hosts themselves unless you're not running a container as a service. If you're using a container as a service product, we don't have the ability to instrument the container hosts because we don't control them. So again, the only place this works is if you build and operate your own container infrastructure and you build automation to instrument everything with intrusion detection. But again, it's an enormous amount of work to do that. And so the question then is should we do it? Then finally, the next option is we do what we used to call host-based IDS, where instead of trying to do it at the network, we give every EC2 instance gets an IDS agent that sniffs the network, that sniffs network traffic going to and from each instance, and looks for matches in the packet data that look like attacks, looks for basically rule matches on network packet data to see if it detects an attack or not going across the network just to and from that instance. This is what I arrived at. This is what I ended up doing. But the results were not quite what we expected. And there are a couple of reasons. There are a few reasons for this. So this is, by the way, one of the reasons we didn't try to use Suricata or Snort. Is anybody familiar with Snort, the Snort IDS? Well, Suricata is a derivative of Snort. It's multi-threaded. It has a bit more features. It's becoming very popular. But Suricata or Snort are both basically, will give you the Snort intrusion detection tool. This is performance data from running Snort on one of my web servers loaded with about 400 connections per second, which is what this instance was rated for. And you can see that 2/3 of the resources are actually being consumed by the Suricata worker process. So this web server is we're actually spending more compute time and money on doing intrusion detection here than we are on doing work. So obviously this was a non-starter, even if we could. Now, the other thing we found is that we got a lot of we got a lot of missing alerts or false negatives where the host-based intrusion detection agents didn't actually detect what we were looking for, what we were expecting. And when I dug into this, the test methodology looked like this. And I say this because, I'll show you this because sometimes people look at this and will say that some people feel that it's not reasonable to try to test the performance of an intrusion detection tool in your environment because these things, in fairness, these things have many tens of thousands of signatures and there are more variables that could run you into millions of test cases, which obviously we can't do that. We're not a test lab. My answer to that is we tested the performance in our environment because in the end of the day, what you really care about is whether these are going to detect what happens to you in your environment. And the set of things that can happen to your instances in your environment is a subset of the things that can happen in the entire world. The set of things that you need to detect is a subset of what it can detect. So we basically, if you wanted to evaluate performance of these things, the easiest way to do it is to take a look at what it outputs during a pen test or a red team engagement. So in my case, I did a lengthy red team engagement on the environment and studied in great detail everything that came out of the IDS. Everything was the real world test cases with real world exploits. Look for things that, so look for vulnerabilities or exploits that came out of your vulnerability scans or pen test history that were used by pen testers successfully. But look for things that could have had critical impact, but you didn't read about them in the news, right? They weren't things like shell shock, heartbleed, et cetera, right? Because the IDSs are always going to detect those because they're famous. And so those go to the top of their priority list for engineering teams. But odds are, we don't just care about detecting whatever the most famous attack is this year. We really need to detect any attacks that have significant risk to us. So in our case, we looked for critical vulnerabilities, critical exploits that were real, that had been present at one time, but were not famous enough to be prioritized by a marketing department. And so the test case and the results look like this. Starting from the top of the kill chain and working down, starting with reconnaissance, like exploration. When pen testers get started and they start enumerating and gathering information about the target, they call it reconnaissance. So starting with the reconnaissance phase, to identifying vulnerabilities, to exploiting vulnerabilities, getting persistence, basically getting access to a hacked web server, installing a persistence mechanism like a web shell or another form of malware. We had some rootkit test cases. Rootkits are just kernel-level malware, which is much harder to see. And then actions on objectives would be things like modifications to users, a copying of data, exfiltration of data, things like that. What we found is that in these test cases, this was a large research project, as you can imagine. But what I found is that in our accuracy, like the accuracy result in that the rate of successful detection that we got was between 12 and 36%. And in some cases, this was due to performance limitations because it's actually not performant to take 80 or 100,000 IDS signatures and load them into memory on every single EC2 instance and try to run every packet through 80 or 100,000 signatures. So you have to pick and choose and make hard choices as to which ones you're going to actually turn on and turn off. In some cases, there were signatures that weren't on. In some cases, there were signatures that just weren't available. There's certain things that just couldn't be detected. So the full set of intrusion detection rules was never really in play here because it just wasn't available. What we did find is that using endpoint data, using other forms of endpoint data, which I'll show you, allowed us to detect things with much greater rates of accuracy. We actually, using endpoint data and switching to behavioral detection, we got into the 90s. We got as high as 93%. So what this means is, basically the takeaway is that we started moving from network to endpoint data because we were just getting more alerts and more accurate threat detection. So let's take a look at some actual examples. So these are some examples that I prepared to try to show you, to try to illustrate for you the difference between network versus endpoint data and how that looks to an analyst and how sometimes we can be more accurate or reach a conclusion faster, get better results with endpoint data. So anybody recognize what this data is first? I always make this presentation interactive because people say that this is the part they enjoy the most. And I realize not everybody has seen data like this before, and I don't expect everybody to know what this is, and I'll walk you through it. But anybody? Yep. So these are flow logs. The flow logs are basically free. You can turn them on and gather flow logs in your VPCs. And they actually kind of resemble firewall logs, but they're a network audit trail. So one of these is a persistence mechanism coming from a web server that's been hacked. Which one is it?
One with all the bytes. The one with the most bytes.
The one with the most bytes would be this guy. Okay. Why? Okay, that's a good answer. But why this one? Why do we think it's because of the most bytes?
Port 22 SSC.
Yep, it is port 22, and it is SSH, I can tell you. That's actually just an SSH session. It's actually not. It's not it.
Would it be the fourth one?
I was looking at the 4.3 forward end.
OK, so this one? Why that one? Well, this is not the exploit, though. This is not the buffer overflow. This is after the exploit. So after the buffer overflow, after the exploit, web server's been hacked, and now the web server is exporting a command shell using a tool called netcat in order to maintain persistence on the web server. So the answer is, those are all good answers, but the answer is it's pretty hard to look at this and pick out which one of these is the attack. Not because there's anything wrong with the data, because there just isn't that much information here to make that kind of a decision.
It's not typical for your server to have ephemeral ports, right? Because you wouldn't expect that to be initiating infection.
Well, these ephemerals are source ports.
Sorry, non-ephemeral, right? So, like, in other words, it seems weird to me that you've got things
like these?
doing connections on standard ports.
Yeah. No, that's a good point. But the reason for that is because these are more like firewall events than flows. These are not arranged by, these don't take into consideration state and who established. So these ephemeral ports, these are actually replies. This is actually the port the service is running on. This is actually a reply from a service to an ephemeral port on a client. And it's kind of hard to glean that from this format. What about here? So here's the same data. Well, it's not the same data, but here's the same event captured by audit D events coming from the Linux instance where the web server is running. Anybody see the persistence mechanism? Yep, so there's the command shell. There's bash being executed. And what's underneath it? So there it is. There's the connection. And here's the process that did it and the user. So much, much easier to make a decision. One, to make a decision and identify where's the attack. And two, to gather enough information to start the basis for an investigation. You can also see further up, these are in ascending time order. You can also see up there that one of the commands that was run in the shell was the cat at the password file. Which is nice, because if somebody does have persistence on a web server, the next question is, well, what did they do? Right? We can't tell what they did from network data, but with endpoint data, we can. And then there's the connection. It's meant to look like a web server connection, but it's not. All right, so what about this one? So in this bunch, there's data exfiltration going on. So somebody has hacked this web server, compromised it, and now they're copying data off the web server to somewhere else. They're actually staging data in order to make preparations to copy it. But one of these is a secure copy session, SCP. Well, which one is it? This one? Yep. OK, good. That is actually it. But here's the thing. If we have a couple million SSH connections per day, how do you pick that one out? Now, you could look at it and say, well, it looks like the byte count is pretty high. But if you've got automation moving files around and doing orchestration, then you could see millions of these per day. So let's look at it in the endpoint data. So here's the same activity from the endpoint data. And you can see, you see that there was a connection to port 22 using the SCP client. But you can also see the name of the file that was copied. And I'm stepping into the light. Don't go into the light. But you can see the name of the file that was copied and the user who did it. So again, now we've gone from, hey, I think there might be something going on, that's weird, to, oh, look, somebody did actually copy data. And here's the name of the user that did it. Now we have a person to ask, say, hey, what's going on? Is this normal? Was this supposed to happen? Do we need to look into it? So those are just a couple of examples. What about these kind of emerging threats that we keep reading about? If people are familiar with, I'm sure you're probably familiar with things like Meltdown Inspector, right? Because they had lots of press coverage. Anybody seen Dirty Cow? Dirty Cow was an interesting one. It was a privilege elevation. But the thing is, for each one of these that you see on TV, there are maybe a dozen others that you don't read about. And these are interesting because these are really just processes running on a server someplace. So how do you detect these with a network IDS? Well, they really don't leave network evidence to detect. So if you're not monitoring what's happening on the endpoints, the only way you're going to detect these is when they try to talk out to the network. But if they make that network communication look normal enough to blend in with the other 5 or 10 million connections that you have per day, it can be hard to see. For things like this, the fundamentals to look for are privilege elevation, a user elevating from user to root, especially when there's no explanation for it. Suspicious authentication events, if somebody does elevate privileges, then they're probably going to switch to authenticated access in order to maintain access. You'll see a weird login from someplace. Weird command activity, anomalous file system writes, and anomalous process activity. We'll come back to this. All right, so let's consider, though, other evasion methods, because we're talking about cloud environments, and cloud environments are not just EC2 instances, and they're not just container instances, right? They're full of services. They're full of database services, file services, and dozens of services that are available from anywhere in the world. They're live on the internet, and all you need is credentials to access them. So how do we detect? So if somebody starts, well, whenever you look at, if you look at penetration test results, or you look at research that's presented in the conferences, most of the time you'll see that people's primary goal is not just to persist on a compromised virtual server. They want to move from the server to the management plane. They want IAM credentials in order to persist in the management APIs in the account itself, because that way if the instance, if the container, the function, the container, the instance, or whatever transient object is that they just compromise eventually goes away, they can still persist in the management plane, because the management plane is permanent and never goes away. So that's really the ultimate goal. So in terms of getting data out, or data exfiltration, usually what you see people try to do is they try to get out of the compromised instance and find credentials somewhere, either in a file or in metadata or wherever they can, in order to pivot into the management plane, and then start doing things in order to try to go unnoticed. Like sometimes people will start a rogue EC2 instance. Just manually start another EC2 instance and maybe even give it its own internet gateway in case you have a network IDS, so it can talk out without being seen. So these are things that, another case is, if you think about how many ways there are to try to get data out, well, we could do an ETL to an RDS instance of ours. We could do a file copy to S3 or to an S3 bucket that belongs to us. Or we could use a message queue, or and there's any number of other methods. So how do we detect these? How do we detect these kinds of threats or suspicious activity with a network IDS, right? We really can't, because this activity, even if you have local endpoints for every service, you're not necessarily going to see this activity in your network IDS because it's largely over TLS, 1. 2, it's not necessarily going to look that different from your normal activity unless you're scrutinizing it very carefully. So what happens though, security teams, I think, were really good at making lists and saying, here's everything we can think of that somebody might do. How do we do it? How do we detect that? But one of the interesting things about security is that threat actors often come in and they do something that we haven't thought of, which is the real challenge. And the limitation of doing this kind of detection sometimes is that we can go and we can make hundreds and hundreds of rules and charts and graphs and analytics to detect everything we can think of, but then somebody comes along and does something nobody ever thought of. For example, here's an interesting example. Anybody read the indictment for the hack on the DNC? It's really fascinating reading if you have insomnia sometime. But here's the thing that interested me. This is something that I had not thought of before, and I don't know anybody who had. Anybody see what's going on here? Well, it turns out that you can actually, if you have a login, you can actually share snapshots with another account. Like you could share my snapshots with your account, and then you could log into your account and you could take my snapshots and do what you need to do with them. You could turn them into volumes or use some other means to. So they basically, if this is correct, they basically did a bulk copy of this data by sharing snapshots. So how can we detect this? Well, it turns out there is actually, who's heard of CloudTrail? It's called CloudTrail. I call it CloudTrails for some reason. But it's basically the audit log of here's everything that happened in your account. And it needs to be enabled in every account in every region. But if you do that and you bring it into an analysis platform, it turns out that there is actually, if a snapshot is shared, there is actually a record of this. And the change to the snapshot would be the first thing that has to happen. So if somebody were analyzing this data, theoretically somebody could have alerted on this and then gone and shut it down before all the data was copied. But you have to be gathering all of this data and doing some analytics on it in order to spot this stuff, especially the CloudTrail data in the case of AWS. And so here's the detail in the event. So for the modify snapshot attribute event, it actually gives you the account name of the account that it was shared with. Not the account name, but it gives you the number of the account that it was shared with, which is enough to go to start an investigation and try to figure out what's going on. So on the subject of the last lesson learned, so one of the major things I found is when I gave this talk last year, I gave the first version of this last year. And the question I got, the overwhelming response I got was, how can we do this without buying 12 or 15 products? How can we do this using open source tools and technologies? Because we'd rather do that. So I set to work on that because I had so many people asking me to do this. So where I've arrived is basically this. Who's heard of the ELQ Stock or Elasticsearch? Anybody using it? You see like maybe 20% of people using it. It's becoming more and more popular. So in my case, the ELQ Stock is the analytics platform, or the thing that becomes what's sometimes called a SIM, or a security information and event manager. So I gather data using Logstash, store it in Elasticsearch, and then do analytics in Kibana and Elasticsearch. And the data sources are these. So primary data sources today are CloudTrails, obviously. Flow logs we need to have, taking flow logs. Firewall IDS events. If there is an IDS or a virtual firewall, I'll take those events and logs and use them, whether it's a network or host IDS. And then endpoint data. So for Windows, it's relatively easy because Windows, we have this thing called Sysmon, which gives us an incredibly rich audit trail of everything happening on a Windows instance with all kinds of data. I'll show you some examples. And as well as the basic of system logs like the authentication log, the application log. I take the Windows Defender log. I'll take anything that's useful. And then on Linux servers, Linux, you need to get something working called audit-D, which is not the easiest thing to do. But if you get it working, that's when you start getting the Linux endpoint data like I showed you a few minutes ago. And to that, I take in system logs and things like web server logs and any other logs from Linux instances that it might be useful. Now, before we go into this, let me show you a brief demo. Let me actually show you what this looks like. So this is a demo instance of this is Kibana, which is kind of like the user interface to Elasticsearch. So this is a demo instance of my stack. So in this instance, let's start here. So this is this connection seems to just drop off intermittently, but it'll come back, or at least it has so far. All right, so this is the Discover tab. This is basically the search interface where we can search any data coming into this instance. And in here, I've got a number of indexes. So I've got CloudTrail data coming from my accounts. I've got IDS data coming from a Suricata Snort instance. I've got Linux data of every kind, Windows data of many kinds. I've got web server logs coming from an Nginx server that's actually proxying this connection. And I've got flow logs. And these are all going into their own indexes, because they're all getting parsed and turned into structured data, structured records with fields and named fields. And the fields are normalized so we can do correlation among the different data types. And then the next step is, once you have all that data coming in, once you have all the data parsing, you can create these visualizations. So this is basically a Linux dashboard, shows us which Linux data types are coming in by volume, commands and command arguments, network connections by process, basically what's talking to the network and what process is doing it. We haven't had a login in the past 24 hours. It would show up there. And here we have, this is the audit. These are aggregations of the Linux endpoint data giving us processes and commands and processes and network connections that are sometimes useful. These kinds of aggregations are often used for threat hunting and anomaly detection. And then over here, there's a whole series of these. So you can do similar kinds of analytics. So these are CloudTrails events. We can see logins, instance activity, method calls, event names by source. Basically, what's going on in the account and where is it coming from. This is what the IDS data looks like. This is data from Suricata. Suricata actually. One of the things you'll hear people say sometimes is that there's no point in running IDS anymore because everything's running over TLS. And well, that is and isn't true. Suricata will actually give you a wide variety of even when you have encrypted data, Suricata will look at things like files where it can. It gives you metadata about TLS connections. It'll give you flow data. It'll give you DNS events. So there's quite a lot you can do. You can also, in my case, I'm terminating HTTPS on my web, on my Nginx instance, which is acting like a balancer. So I'm running Suricata there in order to inspect. This is what the flow data looks like. You can see that the flow data is large in the daytime and small at night. It's often useful to visualize this kind of data, either by time or by country or by port. Sometimes, if something's going on, you'll be able to see it visually here first. So let's go back to this. Because in cases like this, one of the hardest problems in security is, well, what do we do if we don't know what we're looking for? So one of the direction we're moving towards, I think, is machine learning, and I think it's very promising. The machine learning features in ELK, in Elasticsearch, are not open source, and they're not free. They're features that are licensed. So in order to use them, there's some product you have to buy, and that's fine, and they're really great. It's a great implementation that works well. But there is one exception. There's an algorithm available in the open source version called significant terms. It's kind of a fraud detection algorithm. And the way they explain it is that it looks at, so you have to give it two different data points to compare. You have to give it two different fields in an index or two different data sets. And it basically looks for, so you make the first data set is the background, and then the second one is the foreground. And so it's looking for what's unusual in the combination. Basically, it's looking for some unusual activity in the foreground when compared to the background. And the way they explain it is that this is actually an image from one of the Predator movies. And the analogy they use is that it operates sort of like the Predator, in that the Predator looks around and he picks out objects in the foreground that are different from the background. So it's a kind of a difference engine or a fraud algorithm. But what can we do with it? So in the case of CloudTrail, so I've been experimenting with this since I learned about it at ElasticON earlier last month. And the results are really interesting, and I think it has tremendous potential for security and for threat hunting. So in the case of CloudTrail, we can point it at things like event names and IP addresses, and it will find unusual activity coming in and say, hey, these operations were done by this IP address, which is really, really rare, and we've never seen it before. It's extremely rare. In the case of Linux activity, if we run it on the Linux data, we get a couple of things. We actually get both of those examples I showed you. We have the SCP connection here and the netcat process here, both of them being flagged as unusual because the process command combinations are very unusual, very anomalous. So this is interesting because if you do this aggregation, the human activity tends to percolate to the top. And it tends to be pretty good at saying, hey, this is human activity, or I think it's human activity. It's not actually saying this, but it's saying, hey, this is really rare, unusual activity. And most of the time, it turns out to be human. Do the same thing with network activity. It found the network, so doing a network data tuples here, it found the network activity associated with those two. And same thing for Windows. In the case of Windows, this is actually a piece of malware called Mimikatz. It's popular with the red teams. It's been renamed as Google Update.exe.exe. And because we have hashes for programs running on the Windows endpoint, it was able to see that this hash and image name combination is new or rare, and in fact, it's actually malware. So in that case, I didn't get a malware detect from an antivirus agent, but still found it here. So as far as what I would like, so this is an ongoing project that I'm working on. I'm doing this full time now. Basically bootstrapped it myself and doing work now as an ELK or a security analytics expert consultant in order to spend 100% of my time on the project. So what I would ask is, give me, tell me what you would like to see in an open source security analytics platform like this. What kind of data types do you want to see supported? What kind of analytics do you want to, what kind of visualizations, searches, alerts, etc. Because I'm in the process of incorporating as much feedback as I can.
So one question here
Yes.
is like, I'm seeing your visualizations, they're very graph, they're very, like bar chart, and what would actually be more helpful is it like if it's a network kind of diagram, right? This sequence happened before, and
Yeah.
I didn't see anything like those.
In order to get deeper into the data, what I made is not this. Is I've started making a series of event viewer-like objects. Like this is one for flows.
It's still a table, it does not tell you much.
This is more of a forensic tool, right? This is more of an investigatory tool or a troubleshooting tool. In terms of, you'd like to see a map? You mean?
Like a network graph, right? I'm seeing this thing where other places, there's actually an open source thing called lumify.io. Have you heard of them?
I think so. I may have. No, that's actually a great idea. I think there are some mapping capabilities that it can be done natively, but it's more about geographical maps. Being able to have a map or an attack graph is certainly an interesting idea, and it's something I'll probably do. I'll probably work on. Yes. Question?
So you did all this, you've got this analyzed, you get things categorized, you can look at flows, and we've done similar things. And if you've got the right expertise, you can then go in there and look for anomalies. But I think the real magic here is, how do you now create an alert that will automatically generate, because there's no way when the volume goes up, you're going to be able to look at this every day. So the automation of alerts based on these anomalies is, how do you do that?
Sure. So
And I think that's where the value comes in, because not everyone has your level of expertise.
Or even the volume will become too much.
The volume will be overwhelming, the staff won't be able to keep up, and of course there'll be new things.
I'm glad you asked that, actually, because that's kind of the reason I'm doing this, is because I've been an analytics and alert developer for so long. What I'm going to do is I'm going to create an alerts index with a set of probably a few thousand rules, and that will populate an alerts index. And then people can fine-tune and adjust it according to their needs, or I can help do it. And Slack is always crashing on me. And the alerts will go to several places. So that's kind of the problem I solve, is that a lot of people have this stuff running already, but they don't necessarily know what to alert or report on or what's actionable. So the analytics that I'm planning to build are designed to kind of solve that problem. So rather than trying to go heads down and make 5,000 alerts and rules and things, you just basically just use what we've done. And I can show you an example of a Slack alert in here, in our Slack.
But you don't want to have a situation it becomes alert fatigue, right?
Yeah.
That's one of the other problems, is that
But even that,
so these are actually Slack alerts for successful logins. You can send anything natively to Slack. You can send every alert or whatever alerts you wish. But part of the idea is that alert fatigue is a serious problem, but I plan to address that by spending enormous time and effort creating very well thought out, high quality rules and alerts. And then secondly, by providing recipes so that people can fine tune and adjust those to be more relevant in their environment. Because you're right, we're out of time. But you're right, the tuning is one of the hardest things to do in this space. And we are at time, but I'll stick around for questions. Thanks for coming.